Hello viewers, in today's session we are going to discuss another important problem from definite integrals, right? And in this class we are going to find out the value of this expression, that is limit h tends to 0, and we have 1 over h, and the integral from pi to pi plus h, and the integrand is square root of t square plus pi square over 2, and here we have dt, right? So we'll see how we can easily find out the value of this expression using the concept of fundamental theorem of integral calculus, right? So let us see how we can solve this problem. So now let us consider a function, say p of x, that is equal to the integral 0 to x, and here we have f of t dt, where our function f of t is equal to square root of t square plus pi square over 2, right? So here we'll assume a function p of x that is equal to 0 to x, and here we have f of t dt, right? So now from the concept of fundamental theorem of calculus, we can differentiate both sides with respect to x. So we have d by dx of p of x, that is equal to d by dx of the integral from 0 to x, and here we have f of t dt. So this is p prime of x, and here the derivative of this integral, where the upper limit is a function of x, is equal to simply f of x, due to the fundamental theorem of integral calculus. So now we have p prime of x is equal to f of x, and f of x can be written by replacing this t by x. So we have here square root of x square plus pi square over 2. So now this is an important relation, right? Okay, so now let us consider the definition of p prime of x. So p prime of x can be written as the limit h tends to 0, and here we have p of x plus h minus p of x divided by h. So this definition is used here because if we have a function, say y is equal to f of x, then f prime of x is given by limit h tends to 0, f of x plus h minus f of x divided by h, right? So due to this definition of derivative, we can now write p prime of x is equal to this limit. So now we can write p prime of x, and here we have limit h tends to 0. Now p of x plus h can be obtained by this expression. Here we have p of x is equal to integral 0 to x f of t dt. So now if we replace this x by x plus h, then p of x plus h can be written as 0 to x plus h, and here we have f of t dt, and p of x is given by 0 to x, and here we have f of t dt, and in the denominator we have h. Now from the properties of definite integral, if we have this expression, that is 0 to a plus h f of x dx minus 0 to a f of x dx, then the value of this expression is given by the limit from a to a plus h. Here we have a, here we have a plus h, and f of x dx. So now we are going to use this important property of definite integrals to this expression, right? So here if we have 0 to a plus h f of x dx minus integral 0 to a f of x dx, then the value of this expression is equal to this integral from a to a plus h f of x dx. So let us compare this side with this expression. So here we have 0 to x plus h. So 0 to x plus h. So for a we have x, and here we have 0 to x, 0 to a f of t dt. Here the variable is t. So now the value of this expression can be written as, here we have limit h tends to 0. So this difference is now equal to this expression, that is a to a plus h. So for a we have x, so here we have x and here we have x plus h, and for the variable x we have here t. So we can now write f of t dt, and in the denominator we have h. So now we have arrived at an important expression, that is the derivative of p of x, that is p prime of x is given by this limit h tends to 0 integral x to x plus h f of t dt divided by h, right? Now let us replace this x by pi. So when we replace this x by pi, then we get p prime of pi, and here we have a limit h tends to 0 and the integral from pi to pi plus h, and here we have f of t dt divided by h, right? And this expression is the expression whose value is to be calculated, right? And for f of t we have square root of t square plus pi square over 2, right? So we have obtained this expression, and this expression is equal to the derivative of the function p of x at this point, that is pi. Now p prime of pi can be obtained from this expression. P prime of x is equal to square root of x square plus pi square over 2. So now p prime of pi is obtained by replacing x by pi in this expression. So we have square root of pi square plus pi square over 2. So this is square root of 3 pi square over 2, that is equal to pi times square root of 3 over 2, right? So here p prime of pi is now equal to pi multiplied with square root of 3 by 2, and the value of this expression is equal to p prime of pi, and p prime of pi is pi times square root of 3 over 2. So the value of this expression, that is limit h tends to 0, 1 over h integral pi to pi plus h square root of t square plus pi square over 2 dt is equal to pi times square root of 3 over 2.